on the sandblasted specimens hinders the aging. How much, what is the practical, let's say, result of this, we'll have to check. We don't know yet. Well, with that, we made those posts. They are not so simple as the Ivoclar. So we use those results to design regarding the materials, and we made those posts which were then produced by somebody. So with that retentive crown on top of that. Okay, now few more words I see. Running late? What? Running late? Okay, few more. Okay. In vivo, a very simple test was designed. I said, let's have a look and let's have to check the relationship established for the femoral heads. So we have implanted those small discs into a removable denture, 4 specimens into one denture, 2 on each side. We started with 10 patients, and no, we started with 5 patients, so 10 specimens per grade. The specimens were explanted after 6 months, after 1 year, and after 2 years. And I'll show you the results. So the reason why we have chosen the 2 materials, they were the finer grained one and the coarser grained one. And the finer grained size was just below the 0.4 microns, which is, according to the standard, the grain size still allowed. The other one was 0.45 or 46 microns. That's above the value recommended by the standard. I was curious to know whether this makes sense or not and how much. Okay, so these are the X-rays, boring stuff, but we have a lot of peaks, you know. We have tetragonal, we have monoclinic, tetragonal, cubic, we have distorted tetragonal and distorted cubic. It's a mess. But what's important is this result. After the 6 months, we got quite a serious amount of the monoclinic on the surface of the specimens. After 1 year, that goes a little bit up. We lost a patient. 1 patient died. So something I have not encountered, you know, and nobody has, and we were not able to bring him back. And but we were lucky. Now we still have, after 2 years, 4 patients, so 8 specimens. Now, these are the results. I was shocked at the beginning, so we also inserted a couple of polished ones. 2 patients were polished specimens, and you see the amount of monoclinic on the polish is much lower than in this rough surface of the sintered material. And when we checked that, we have done this in vitro experiments, we established this relationship. These are the experimental data from the in vitro experiments. And if we put the points from in vivo, we got this relationship. So it's if we just compare these two, you see that they are quite different, you know. The femoral head and this one behave differently. Okay? And this is some microstructure. This was the surface, you know, that it was rough. It's like you have after soft milling. And Okay, after 2 years, that's interesting. You'll really see kind of, cracking of some grains will start cracking. But if you calculate, that's a good message. If you calculate the amount from the amount of the monoclinic on the surface, the thickness of the transformed layer, it roughly corresponds to a grain size, 0.4, 0.3, 0.4 microns. It's not a big. It's not a thick layer that is transformed. And this is the message we have to. We dare not just take the one relationship and generalize it for any material. Okay. Last thing, perhaps that make. I have to wake him up, Bob. No, alternative. No. His no. Okay. I heard that much that sandblasting is not good. Sandblasting is dangerous. So then I said, okay, let's have a look. Perhaps we can get an alternative solution that won't damage the surface. So, being inventive, I used something which everybody can buy. It's aluminum nitride powder. Aluminum nitride is a powder that reacts with water and forming aluminum hydroxide and ammonia that you smell. But it's not dangerous if the concentrations are not high. And this aluminum hydroxide will form lamellas, a network of lamellas perpendicular to the surface of the substrate. And if you heat that up, you will first lose the chemically bound water, and then you'll go through the whole, sequence of transient luminous gamma, delta, theta, up to alpha. Alpha is 1100 or 50 degrees C. But we stopped before that. And after precipitation or after deposition of this layer, the adhesion of the layer to the substrate is very weak. You can remove it by a Scotch tape, But after a heat treatment, 900 degrees C, you get the opposite situation. This is the glue, so you remove the glue from the tape. So it's it adheres, the coating adheres very strongly to the surface. And another good message is that the cements or glues, perhaps this was a glass ionomer. That's very good. The organic part, that's very good. Those coatings, you'll find them everywhere. So how it looks like on zirconia, on alumina. This is on sandblasted alumina. So it goes inside from everywhere. And Peter Jonica, he tested two sorts of cements, and in both cases he found a much better adhesion even after thermocycling. So there is an alternative, but according to Matthias, that it's not necessary. Because that takes that's another operation. Okay, you can deposit the layer very quickly, but then you need another heat treatment, and that takes perhaps 10 hours, 3 hours. Excuse me. And if this is not necessary, why bother? But if there is a problem with sandblasting or somewhere else, that might be a solution. Okay, so that's a pretty, let's say, that's one of the possible solutions, I will say. And with that, I would like to acknowledge Andras Kotyan. He did his PhD study on this aluminum nitride stuff. The Oblak Jonica are dentists. I was supervising their PhD thesis at the university, and somebody had to give us money for that. And I would like to thank you for your patience. Okay? Thank you.